Chromatography is used to separate mixtures of substances into their components. Chromatography can be done a variety of different ways, but all the ways have a mobile phase and a stationary phase. In paper chromatography, the stationary phase is the paper, and the mobile phase is a liquid solvent. It can be used to separate dyes into their component parts and identify substances. The solution that constitutes the mobile phase travels up the stationary phase, carrying samples with it which travel at different rates. The solution is nonpolar, and how far each substance travels depends on the polarity of the dyes. First, a horizontal line is drawn on the bottom of both me and my partner's chromatography paper. Then small drops of each of the dyes in the unknown dye are added to the line on the bottom of the paper with capillary tubes, making sure to secure ample separation between dyes. The chromatography paper is placed in a small amount of nonpolar solvent, making sure the solvent does not touch the bottom line on the paper. My partner and I each made one chromatography paper because we used two different nonpolar solvents. One was a 1:1:1 ratio of water, acetone, and propanol, and the second was a 1:1:1:1 ratio of water, acetone, propanol, and acetic acid. The papers were straightened in the beaker and made sure they were not curled, and the beakers were covered. After 15 minutes, each paper was removed, and my partner and I both calculated the RF values for each dye from our paper. The RF values are calculated by dividing the distance each individual dye travels up the stationary phase by the distance the entire solvent traveled up the stationary phase. Watch as my partner makes these measurements. We also discovered the identity of the unknown dye by looking at the chromatography paper because each component dye was visible. We also discovered that the 1:1:1:1 ratio solvent gave the best separation.